When we think of a map, we usually picture a static, unchanging guide to our world. But what if maps could think? What if they could see patterns in real time that are completely invisible to us? Well, that's exactly the promise of the GeoAI revolution, and we're about to break down how it is literally redrawing our world as we speak.
It all really starts with this one huge question that kind of shakes up a classic scientific ideal. What if the messy, complicated, unpredictable reality of our planet just can't be boiled down to a few elegant, one-size-fits-all equations, like you might find in physics? This is the core problem that a whole new field is trying to solve.
See, for a long time, the field of geography kind of had an identity crisis. It really tried to be like physics, searching for these simple, universal laws that would apply everywhere all the time. But the thing is, the real world, with all its local quirks and beautiful complexities, just refused to fit into those neat little boxes.
And by the mid-1980s, it was pretty obvious this approach had hit a wall. As one source puts it, the attempt to make geography like physics had run its course. The world was just too complicated, and that became a huge turning point, creating this urgent need for new techniques that could actually handle the messiness of real-world places.
So a brand new idea started to bubble up. Pioneers like Stan Openshaw and Jerome Dobson, they argued that, hey, instead of trying to force our data into simple models, what if we let the computer become a partner in the discovery process? They were already imagining geographical analysis machines and a future of automated geography. They were really setting the stage for what was about to happen.
And that brings us right to the hero of our story, GeoAI. It's the answer to all those challenges we just talked about. So, what is it exactly? Well, at its core, Geospatial Artificial Intelligence, or GeoAI for short, is this incredible fusion of two powerful fields. It takes location-based data and analysis, that's the geo part, and combines it with the pattern-finding superpower of modern artificial intelligence. The whole point is to help us make sense of the where. Now, this revolution didn't just pop up out of nowhere. It was really made possible by a kind of perfect storm of three huge technological forces coming together. First, massive breakthroughs in AI itself. Second, the absolute explosion of geospatial big data coming from our phones, from satellites, from sensors everywhere. And third, a quantum leap in computing power, especially with GPUs, which are just perfect for this kind of work. And when we talk about geospatial big data, what are we really talking about? Well, it's pretty wild. We're talking about everything from continent-spanning maps of every single building on Earth to the precise GPS tracks of migrating animals. It's our own anonymized GPS trails, our social media posts, and this constant, unending stream of high-res satellite images covering the entire planet. This is the fuel for the GeoAI engine.
Okay, so that's all the theory. But where does the rubber meet the road? Let's dive into how this technology is actually being used right now to take life-saving action out in the real world.
All right, let's start with one of the most critical applications there is, disaster response. This is where speed and accuracy can literally mean the difference between life and death, and GeoAI is completely changing the game. Okay, picture this. A hurricane has just made landfall. In the immediate aftermath, AI can scan satellite images to instantly map building damage on a massive scale. Systems like something called Victim Finder can automatically sift through social media looking for desperate calls for help. It can even analyze Twitter data to see if evacuation orders are actually being followed and, importantly, reveal how these disasters hit different communities in very different ways.
Now, the next huge arena is public health. GeoAI is giving us this entirely new lens to understand our health, not just as individuals, but across whole populations in the environments where we live.
I mean, think about it. We can now predict the spread of a virus by analyzing large-scale, anonymous patterns of human movement. We can get a pretty good estimate of the diet and physical activity levels of an entire neighborhood just by looking at location data. We can even spot the very beginning of a flu epidemic by analyzing Google search queries in a specific region. It's an absolute game changer for public health.
And the impact doesn't stop there. GeoAI is also becoming this indispensable tool for tackling some of our planet's absolute biggest challenges, from making sure we have enough food to eat to fighting climate change.
From way up in space, GeoAI models can estimate crop yields with incredible accuracy, which helps us manage global food supplies. It can forecast how climate change is going to impact fragile ecosystems. It automates the painstaking work of mapping terrain, and, this is really cool, it helps humanitarian groups create up-to-date maps for parts of the world that have never been properly mapped before. So, look, GeoAI is clearly an incredibly powerful tool. But as we all know, with great power comes some pretty profound new responsibilities that we all have to start grappling with.
So you have this incredible promise on one side of the coin, but on the flip side, we've got some serious challenges to wrestle with. How do we make sure these super complex AI models are actually reproducible? How do we protect the privacy of every single person whose data is being used? And maybe most importantly, what are the ethical lines that we simply cannot cross?
And to really put a fine point on the ethical stakes here, two researchers, Dobson and Fisher, coined the term geoslavery all the way back in 2003. Now that is a powerful, provocative word, and it's meant to be. It's a warning about a possible future where constant location tracking could be used to control people and limit personal freedom. It's a stark reminder that we have to build these systems with incredible care.
Ultimately, what this all boils down to is a fundamental shift in the questions we ask. For centuries, science was focused on what happened, or when it happened. Now, the most important question is becoming where. Where are the patterns? Where should we intervene? And where are we all heading? We're drawing the map to our own future in real time. And the biggest question of all is, how will we answer?